Good, good morning to all. I am Nivita from Kongonadu College of Engineering and Technology. Now we are going to see the topic about RAID. RAID means Redundant Array of Independent Disk in DBMS. Okay, Redundant Array of Independent Disk, which combines multiple small, inexpensive disk drives into an array of disk drives, which yields performance more than that a single large expensive drive. Okay, RAID is also called a redundant array of inexpensive disk. These multiple secondary disks are connected together to increase the performance, data redundancy, or both. Storing the same data in different disks increase the fault tolerance. Okay, the area of mean time between the failure is equal to the mean time between the failure of an individual drive, which is divided by the number of drives in the array. Because of this reason, the mean time between the failure of an array of drives are too low for many application requirements. Okay. Next, why we are need RAID levels to increase the performance of a database and then increase the reliability to give greater throughput. Finally, data are restored. First one is a RAID level 0. RAID level 0 is a not redundant. Since no redundant information is stored, performance is very good. But the failure of the any disk in the array results in data loss. A single record is divided into strips, typically 512 bytes, and is stored across all disks. The record can be accessed quickly by reading all disks at the same time is called stripping. This the data is broken down into a blocks. These blocks are called stored across the all disk. These data are stored in all disks. This striped array disk is implemented. There is no duplication of data in this level. So once the block is lost, then there is no way recover it. It has a good performance. And then RAID level 1. RAID level 1 provides the redundancy by rating all data into 2 or more drives. The performance is faster on reads and slower on writes compared to a single drive. If any one drive fails, no data is lost. This method is called mirroring. The RAID 1 is also called mirroring. Use mirroring technique. All the data in drives is duplicated to another drive. It provides 100% redundancy in case of a failure. This in this step, its advantage is fault tolerance. And then RAID level 2. RAID level 2 used the Hamming error correction codes and is used with drives which do not have a built-in error detection. Use a mirroring as well as stores error correcting codes for its data striped in a different disk. Each data bit as a word is recorded on a separate disk, and ECC codes of the data words are stored on a different set disk. Okay. Next, due to its complex structure and high cost, RAID 2 is not commercially available. And then RAID level 3. It consists of a byte level striping with a dedicated parity. In this level, the parity information is stored for each disk section and written to the dedicated parity drive. At the RAID level, stripes the data as a byte level across several drives with the parity stored on a one drive. Byte level stripping hardware supports efficient use. Parity is a technique that checks whether the data has been lost or written over that when it is moved from one place in storage to another. And then RAID level 4. It consists of black level of stripping with a parity disk. It's a RAID level 4 that has a stripes data as a block level across several drives with the parity stored on one drive. Parity information allows recovery from the failure of any single drive. The performance of the level 4 array is good for reads. Writes, however, required the parity database updated each time because only one drive in the array stores the redundant data. The cost may be some megabyte is very low. And then RAID level 5. RAID level 5 writes whole data or blocks on different disks but the parity bits generated for data blocks are distributed among all the data disk rather than storing them on a different dedicated disk. And RAID level 5, it's a similar to level 4, but distributes a parity among the drives. This can be speed up small writes in the multiprocessing system. The performance of RAIDs is lower than level 4 array. The cost, but the cost is as a megabyte is same level as 4. And then RAID level 6. 6 is extension of a level 5. In this level, two independent parities are generated and stored in a distributed fashion among multiple disks. Two parities provide additional fault tolerance. This level secures at least a 4 disk drives to the implement RAID. Finally, give the summary of RAID level 0 means it's a faster and most efficient array type but offers no fault tolerance in RAID level 0. And then RAID level, it's an array of choice for a critical fault tolerant environment. In RAID level 2, it's used to today because of ECC is embedded in almost in a modern disk drives. And then RAID level 3 means it's used to single environments which access the long sequential records to speed up the data transfer. And fourth level means it offers no advantages over RAID 5 and does not support the multiple simultaneous write operation. In RAID level 5 means it's the best choice in a multi-user environment. However, at least the 3 drives are required for the RAID 5 array. And then RAID 6 is the levels requires at least a 4 disk drives to implement the RAID. Thank you.